Hello students, in this video I am going to go over assignment U1A00C, which is isolating unknowns, isolating variables, by using the four operations that was discussed in lesson U1A00. So in this lesson, or in lesson U1A00, we went over PEMDAS and orders of operation. So whenever we're trying to isolate an unknown, by using or by undoing the operations within PEMDAS, we have to go in reverse PEMDAS order. So let's take a look at some examples here. And I know this is not the first time that you're seeing this, so I'm just going to go through it and just demonstrate some examples for you guys. So let's take a look. We're trying to isolate A here. So A is the unknown that we're trying to isolate, or A is the variable that we're trying to isolate. Even though there are no numbers here, let's not be fearful of this because this is all treated the same, just like numbers. So I noticed that that A is being multiplied by M, but then that product's being added by B. So I need to go in reverse PEMDAS order. So what am I going to do? I notice that there's an addition there. I will have to perform the addition first before I undo the multiplication. So what am I going to do now? I am going to subtract B from both sides. And what I'll end up with is Z minus B is equal to MA. And then what I'll do is I'm going to divide both sides by M. And I'll be left with A is equal to Z minus B over M. Let's do another one. Here I need to isolate A. So I notice that there are things being added and subtracted from A. So there is no particular order to do this, and as a matter of fact, you can do it all at once if you'd like, because remember, addition and subtraction takes no particular order. Same thing with multiplication and division, takes no order. So let's take a look. So what I'm going to do is I'm going to subtract K and add B to both sides. And if you do this, you'll end up with U minus K plus B is equal to A. That's all it is. All right. Next, I'm trying to isolate A here. And it looks like, so right now I have this, this fraction going on. And this fraction looks rather intimidating. And I have A in both the numerator and denominator. So to approach this is, well, I can't just divide out A because there's a sum up top, okay? So what I'm going to do is I am going to multiply both sides by CA first. And actually, let me just go. So I'm going to take this, I'm going to multiply both sides by CA. I'll rewrite everything because I don't have enough room there. So I'm going to multiply both sides by CA. So I'll end up with CAG is equal to A plus B, because the CA's on the right will cancel. Now I have A's on both sides. I need to bring over everything that has A. So I'm going to subtract A from both sides. And then what I'm going to do here, notice now there's a common factor. So what I'm going to do is I'm going to factor. And the act of factoring is very much like division, right? So I'm going to pull A out. So I'm going to pull that out. So I'll end up with CG minus 1. If I were to redistribute this, I'll end up with CAG minus A, right? So I'm undoing that. Equal to B. So therefore A will equal, and then I'm going to divide both sides by CG minus 1. So therefore A is equal to B over CG minus 1. All right. And the last question here, I'm going to solve for x. Now I notice that on the right hand side there's x's in both, and x is all on one side already. So what I'm going to do is I am going to factor out x. So z will equal to m plus y times x. I want to divide both sides by m plus y. So if I do that, I'll end up with x is equal to z over m plus y. And that's it.